This episode is sponsored by my husband. He is one of the hardest workers I know. And thank you, husband, for sponsoring this show and for all of the previous shows. Let's get into it.
Lisa LaBelle, everyone!
Hello, world. Welcome to the L4 Podcast. I'm your host, Lisa LaBelle, the technology comedian. What's going on, all you gasoline sniffers and kerosene hitters? What's up? It's July 4th. Today is July 4th. Happy Independence Day. I hope everyone's having a good time out there. And if you're listening to me from somewhere else in the world, I hope you're having a good day. Just a regular good day. It's balmy out there. It's quite warm. It's hotter out there. It's hotter out there than in Florida, and that's all I'm going to say. I mean, what's going on? It's hotter up north on the East Coast than it is in Florida. Super weird. Are the poles flipping? Maybe. But it's a good day, and you know, I hope all y'all, some of you might be at the ocean. The ocean's wide open. Get yourself in there. Get in that ocean. Do you guys do the whole, like, you put your shoes at the, you know, wherever your station is on the beach, and then you put your wallet in the shoe, and then, like, do you guys still do that? Where do you put your phone? I don't go in the ocean. It's not, I can't control anything in there. I don't go in it. No thanks. But I know some people, they just don't care and they really enjoy it. So I hope that's what you're doing today, or being out on a lake, or having a cookout. That's always a fun thing. Cooking up some hamburgers, hot dags. Those hot dags with the buns. Mac and cheese, you got the macaroni salad, you got all the good stuff. Hope you're having fun today. And I hope you're having a really good weekend. Summer is the best, man. I mean, it's good. It's good. I prefer the colder weather, but it's good. Summer's always great too. It's great. Let's get on with it. That's Scott Miglion, I Need Your Love. That's what we're talking about. Talking about love, man. I hope you love something. Either a human being, an animal, a hobby, something, man. Something. I hope there's something going on in your life you love. The Lord. Glory to God. Let's go. Let's go. You know, this is the time, the season, where you go get your bathing suit. Because you're probably going to go in water somewhere. You're either going to go in a tributary or a lake, an ocean, somewhere. You're going to need a bathing suit. And ladies, I don't know if you ever came across those reversible bikinis. What? You can get one bikini and have two looks. Ooh, that's a bang for the buck right there, isn't it? Two looks. Two looks for one price. No, don't do it. Stop it. Stop doing that. Companies that make bikinis, stop. It seems like a great idea. Then you get it. And usually the one side of the bikini is a solid color. And the other side, it's going to be a loud print. Like big old flowers or paisleys or something. And then, but when you decide to wear it on the solid color side, the paisleys or the bright print, it shows on the edge. It shows on the seams. It like bubbles towards the front of the solid print. So you're seeing it, and then it just looks like you put your bikini on backwards like a Mayron. And then that whole two look thing for one price, it's not working out. Stop doing that. Stop. I've yet to come across one that can do the seams right. So that's just my thoughts on it. And I know that other ladies, they came across this too. We're done with it, man. We're done with the reversible bikini. Because we're done looking like Mayrons. Like we can't get the bikini on right. Like we're walking around like we're wearing a bikini inside out. When really we're just wearing it like we're supposed to. No. I got some new swim trunks for my husband. He like them. Now we're just trying to decide where we're going to go and use them. But usually you're going to have a destination in mind and then you buy the thing. But sometimes we'll buy the thing and then we'll plan around that. Like a very specific thing, like a swim trunk. Well, it's very specific and there's only one thing you do with that. You're going to go in some water. So we're figuring that out right now. We're figuring that out. Well, not right now. My husband's also working. And I'm here with you. I'm here with you guys. And I love it. I love it so much. Thanks for listening. Thank you, everyone. Each and every one of you. Thanks for, I got TikTok, Instagram, YouTube, X. Those are the main platforms. Thank you. Everyone on there, thanks for listening. Appreciate ya. Appreciate y'all. I do want to say shout out to my husband. Last episode I mentioned we're just swimming in this world of technology. AI, we learn about a lot. I expand and I go into space exploration because I just love that. I freaking love it, man. Engineers, I'm so excited. I got a brain bubble. What I'm going to say. Space exploration engineering. Do I understand it to a technical level? Not quite. But it is quite amazing, and I do respect anyone that can wrap their head around like heliophysics or engineering a spacecraft. Things you gotta worry about up there, like cold welding. There's no oxygen up there to keep the iron apart from each other, and then they just kind of fuse together. So you got to figure it all out, iron, steel, whatever. So there's so much that goes into it, and I just respect anyone out there who can wrap their heads around it and execute. It's amazing. It's incredible. A little absurd. That's how I like it. So my husband and I, he mostly studies technology. And we both do research on AI and robotics. Because I mean, you know, I'm not quite in that world of SaaS. We're talking about software as a service. Get those words out. Software as a service. SaaS. Some people in the business, Jamal Tapatio, think that SaaS is not going to exist. It might just kind of fade out. I'm not sure what my husband's thoughts on that is, but you know what? I'm going to get him on this podcast. We're going to talk about it. I think the world is going into a direction of RaaS. And that's how it should be said, and that's how any salesman should say it. Would you like a RaaS service? That would be robotics as a service. So we talk about these things at night about around 9:30. We get together, we sit on the couch, and that's my husband's word. And it's right. That's the right way of using it. We sit on the couch. We go and sit. And I'll talk to him about what I've learned that day, and thank God his mind works. What he can do is take a very complex technical thought, very complex technical idea, and shave it down to something super simple to understand it. And that's what he does for me. And that's great. Because I've been, you know, with that real-time action chunking and inference. You got resources. There's so much information out there, and he's able to put me on the right path with that. And I'm thankful for it. And man, this week I've been studying. We're studying vectors. We meaning me and just me. And I'm studying vectors. My husband is also studying vectors too. We were studying it together a little bit, but then I was doing my own research on it. So I'm studying vectors. I'm studying parameters. I'm studying tokens, vectors, parameters, action. Where's that? Attention. Semantic clustering, and what all of this I am talking about. I'm studying this in the context of how robots learn. That's what I'm interested in. And a lot of it has to do with large language models, how they learn. And then also you can parlay that into how a robot learns, a VLA, that's a vision language action model, which is a humanoid. And They have some real-time action chunking. And man, it's just a lot. So I was going to talk a little bit about that today, but I decided I need to wrap my head around that just a little bit more before I dive into that with you guys. But I am excited to get into the technology segment of this podcast today. Before I do that, I got to tell you guys, my husband and I, since we get together that late at night, we sit on the couch and we'll talk about that AI robotics. And then sometimes, you know, it's so late, our brains are just a little bit like ready to relax. and then it just turns into something real cheesy and funny. So I'm over there, I'm getting some honey. I'm getting some honey as a little late night snack because I am Winnie the Pooh and I just eat honey all the time. So, and I said my husband, what is honey? Like, what is it? What is it, man? It comes from bee butts. That honey come from bee butts. And he said, well, I think something like that. And, yeah, he said, well, what if we get a honey company? What if there's a honey company, we name it Bee-Shite? Bee-Shite. Put it in your coffee. Put some of that Bee-Shite on your bread. bee shite. And bee shite it's bee poop. Really, it's just coming out of the bee butts. Bee butt shite. Put some of that bee shite in your tea. Be shited up. I think that's great marketing. And if I had a honey company, that's exactly what I would call it. So, I mean, bee shite. Come on. Bee shite. Bee shite that bread. Bee shite that coffee. Bee shite that cracker. Bee shite that challah bread. Anyway, moving on. I had... If your skin want to glow, ladies, you put some of that bee shite on your face. Okay, next. I had we're just, you know what's going on. I am just keeping it. I'm keeping the stage, fair for everyone. That's all. I'm just keeping it humble up here, keeping it fair for everyone. This week I had a podcast. I'm sorry, excuse me. This week I am doing a podcast right now. Last week I had a Zoom call with a fellow comedian. Shout out Timmy. I'm sure he don't like that. Tim Conniff. Maybe he does. Tim Conniff, if you're listening to this, shout out. I will put his LinkedIn information up. Tim Conniff, he is from Doylestown, Pennsylvania. That's where I don't know if he's from there, but he resides there. And let me tell you, I'm from Pennsylvania, and I have family members in Doylestown, Pennsylvania. That's D-Town. That's what I D-Town over there, Doylestown. It's the cutest town you will see, and it has a lot of Pennsylvania Dutch, I'd say, attributes about it, and that little Pennsylvania Dutch, a little bit of that Amish, little markets out there, little honey, some of that bee shite honey. But Doylestown is great. It's a great community, and my family members who live there are very involved in that community. And Tim Conniff, he is also very involved in that community. He's a very involved, active comedian, corporate, small businesses, and also regular stand-up shows. He does the gamut. And Tim, I just want to give you a shout out. He reached out to me. He wanted to connect with me and via Zoom, and it was amazing. I love connecting with fellow comedians. It's my favorite thing about this journey, this job, is connecting with fellow comedians because, man, they know the grind. You get a good comedian like Tim, and and who understands the writing process, and everyone has their own writing process, and I love hearing about that too from other comedians. Like, hey, what do you do? How do you work a bit out? How long? Like for me, I'll have a bit in my head. I think of it as a seed. I'll kind of mull it over in my brain. I'll write it out a little bit. For me, you got to write a lot in order to get the gold. I mean, it takes a lot of writing, many, many hours just to get a banger. And that's what I call like you are collaborating with the universe. You're collaborating with the universe, and you're working through things. You're looking for those gifts. You're going down you're going down this road and that road with your new bits and your new ideas, and you're writing it down and working it out. And so I write it down. I go and I work it out. I'll work it out on here sometimes with you guys. And then it molds into something with structure, and then it starts getting some wheels on it, and it starts gaining traction. And so that's how I work my bits out. And I got to hear a little bit how Tim works his writing and his bits out, which was really cool. And just hearing about his journey was really great. And we're all in this together. So it's, and the feeling of like bombing is real. Just eating piles of shite. Now that's not piles of bee shite. If we were eating piles of bee shite, everyone would be doing this because then it'd be really good. No, this is like regular shite. And that's something you got to do it. And it's a long game. So you got to just strap yourself in, guys. Strap yourself into that. That's going to be a raw vehicle. You're strapping yourself in to get that 3-point harness. Get your helmet on. Because you're in for it. It's going to be great. So that was really cool. Shout out Tim Conniff. Thanks for connecting with me. And birds of a feather flock together. That's where it's at. And I also connected with via LinkedIn Joel Byers. He is I guess you call it a quasi celebrity here in where I am in the town around Atlanta here. And I connected with him over LinkedIn, and that's great. And so it's just cool connecting with other comedians. And I love collaborating, with other comedians. Now, stand up it could be a lonely road because it's just you and the universe, and you're just working it all out. And then you got, I've got improv. I love improv because I love collaborating with fellow improvers. And the troupe I'm in is called a Broken Chair Improv Troupe. Trope it up. And it's just a great group. Everyone loves comedy, and that is so fun collaborating with other people. And also hearing, we got a great instructor, and he's been part of the group. Shout out Joe Lamo. Whoop whoop. And he's taught by a world-renowned improver. And I think the group, my group would totally agree with me that he is the best. He's the best. So I've been feeling really super blessed about that, and being able to collaborate with others. So get out there and collaborate with others, guys. Get on out there. Get yourself into a class. Even if you're not doing it for your profession, get out there and go get yourself in a class. It's a great community. And now I'm preaching, but I'm a super fan of the improv. Super fan. I am upcoming thing. So I am working on a technology improv show, and it's like sketch comedy meets improv. And I know that's not pure improv, but it's my show, and I'ma do whatever I want. Meaning, I'm gonna do whatever I think the audience wants. I got a pulse on the audience out there, being a stand-up comedian, and so I'm gonna do what I think they want to see. And you know what? Sometimes people want to see something different. And actually, it doesn't matter. It just needs to be good. And this is how I'm going to make it good. So that's a tech improv comedy show. And then also I'm working on my material for my upcoming tour. Lisa LaBelle, the technology comedian, presents The Robots Are Coming. Are you ready? That was a long pause for anyone who's just listening to this, and I apologize about that. So that's the tour. The robots are coming. Are you ready? And what I'm doing is I am ushering the AI and robotics revolution with peak absurdity. And I know one of those shows that's going to be in Reno. It's going to be in Reno. My husband said, he said, where's Lisa? She in Reno. She in Reno doing her show. Where's Lisa? She's in Reno. Or I'm making chicken, because I make a lot of chicken. But those are the things I'm working on. I will keep you posted with dates. And also another thing I'm working on, and I want to get your guys' thought. I want to get your guys', all you guys out there. Hey, you guys. That's from the Goonies. And that's the only thing I know from the Goonies. And I have not seen the Goonies, but I know there's a kid in there who says, hey, you guys. And then there's a kid that does the truffle shuffle, right? The truffle shuffle. Anyway, that's all. I mean, I'm probably not doing that accurately because I never saw the movie. But I am going to reference it because I like it. It's funny. And growing up, my beloved stepmom, she would, to make me laugh as a kid, she would say these lines like, do it the truffle shuffle and hey, you guys. It's the best thing ever. So I want to get your guys' thoughts or opinions on, would you be interested in a cyborg-centric DC Studios film? And I know they have Vic. They got old Vic Stone. They got Victor Stone. And Victor Stone, he would make an appearance. But this is not he's not going to be the protagonist. And what I mean by that, he will not be the main dame, the main dude, but he will make an appearance. And this show, and this is my way of copywriting it, DC Studios, I want to build with you. I brought this idea up to Mr. Sir James Gunn over there at DC Studios. And it's a cyborg-centric film. And that would be featuring a AI cyborg superheroine. Hang on, guys. Don't put me down yet. It's not going to be one of those, female power. Not like that. But it's going to be, she's just going to be the protagonist. And what we can do, guys, here, bear with me. Come on. Keep on with me, guys. Keep it with me, okay? We got a AI cyborg superheroine. Okay, she's from a planet, and this planet, she got a brother. She is raised by her grandfathers. Her grandfathers, they are gay, and they adopted her. Her and her brother, they raised them, and then she had to get out of there. She had to escape. Her grandfathers told her she had to escape because there's a nefarious human overlord who's taken over the planet. And now the two grandfathers, we're talking Terry Crews and Bob Odenkirk. All right, that's the two grandfathers. And this nefarious human, he got issues. And so he taken out. So her and her brother, they went on down to Earth to get away. And she's tough. She's a tough cookie, but she got a heart of gold. She saves a robot named Giblet from a trash compactor. Some billionaire didn't want him anymore. Put him in the trash compactor. She saved Giblet. Giblet's a little awkward. Giblet, he wants to be loved. He wants to be loved. And I think like Burt Reynolds is his favorite actor. He just loves old movies and, Casablanca, he loves that. And so he just wants to be loved by everyone. But he'll go up to someone at a party and we're in the future, okay? We're talking a dystopic future, but Giblet, he has a medical screening technology, so he can screen, because he was owned by a billionaire, so they can screen you and tell you how your blood is doing, how your body's doing, all this. So he's able to screen people, and not to be weird, but he does it, and he's like, hey, so he'll go up to Kylie at a party and be like, hey, Kylie, how's that yeasty foot doing? You got a yeast infection on your foot. I hope you're taking care of it. How's it doing? And he'll just announce it to everyone at the party, and she's not happy about that. So Giblet, some people don't understand Giblet, but the protagonist loves Giblet. So she adopts him, and then she adopts a disabled homeless boy off the street, and he has a beloved raven, a cyborg raven who helps him on the street. And it's just this beautiful misfit family. And Vic does come into the scene where they have to save Earth from the nefarious villain that took over the cyborg world. And her love interest, she's not really interested in anyone, but it's gonna be a stand-up comedian, okay? That's gonna be great. And her love interest is going to be a stand-up comedian, and he's trying real hard to get her attention. She's trying to find a scientist, a doctor who can save the disabled homeless boy that she adopted. And the comedian, he's trying his hardest, like he's going to go on this journey with her and go find this quirky doctor. So that's it. That's my idea. There it is. There it is. And I think, places they're sourcing from the public because there's some really great ideas out there. And, doing this arcane, well, this is how you submit your idea, and then we own the idea, and then you gotta put on the paperwork, and then you gotta do this, and you gotta do that, and then you never hear from us again, but you're gonna see your story on the big screen. No, people are not doing that. Some people might be doing that, but you cannot, like, you're just going to stunt the creativity with those kinds of bureaucracies in place. So Amazon, people, Marvel, and they're smarten up. You're smarten up. You're going to get smart. You're going to start listening to these ideas out there on the social media. Anyway, moving on. That was long-winded. Let's go. I am so excited. Man, Jensen Hung, man, we're talking about NVIDIA. He has a new Disney droid. And I'm going to pop this video up for you guys. A few months ago, I did a whole podcast about the NVIDIA GTC 2025 conference. And I talked about a lot of the robots that were there and the new technologies that NVIDIA was announcing. And one of those was Little Blue. It was a little droid, and it kind of looks like a Star Wars droid. And it's a Disney Star Wars. It's in collaboration with Disney. And they trained Blue on NVIDIA's Newton. And which sounds like Isaac Lab. Project Newton, it's a physics-based reinforcement learning framework designed to simulate and train robotic movement in realistic environments, and allows for highly efficient learning of physics-based skills in a virtual setting before deploying them in the real world. And that was Blue. So I'll pop that up just so you guys can see. Blue, the cutest thing in the entire world. Okay. So now the new droid is Grek. And this is at the Vivitech in Paris, and that was just a few months ago. And I'm loading this video right. Oh my god. Oh my god. This is the cutest thing ever. Oh, I got to put the sound on. Because it's so cute.
Obeying the laws of physics. And so you learn how to walk in the virtual world, and look at you now. Can you jump?
It's jumping, guys. It's jumping. Blue did not quite have this gait. It didn't have this range of motion.
I just want to let you know, I am the keynote presenter.
And that's Jensen Hung talking.
Could you sit? Sit.
Of NVIDIA, the NVIDIA CEO.
Hey, you know what we should do? Let's take a picture of everybody.
So this droid it's taking a picture.
Bam.
It got a little thing on the side of its head. It's taking a picture. It's incredible.
Your name is Greg. Greg
This is the beginning.
is a little girl. Greg learned how to walk
They give it a
inside
gender.
the Omniverse, obeying the laws of physics. And so you learn how to walk in the virtual world, and look at you now.
Oh, it's so cute. Oh my god, guys, it's the cutest thing in the entire world. Oh my god. Can't handle it. Oh my god. Greg. Need one of those. Just want to hug it. I just want to hug its little Greg face. It just love all the little noises it makes. It's so freaking cute. So they're going to be walking around Disney pretty soon and just talking to people like with its little noises. Oh my god, so freaking cute. Now, Greg was trained on. I'm thinking here. Let's see. Bear with me. Isaac Lab, I do believe. Let me just double check that. Bear with me while I'm double checking this. Can you hear me typing? I just want to double check before I just move on, and I just want to fact check myself. Based on the information available to the current date. Let's see. Okay, I'm not getting what I thought I'd be getting. Hang on. All right, now we're up. We're up and running now. Here we go. Come on, man. Come on, man. I'm using a large language model, and this one is, Grok's okay. ChatGPT is a little bit more intuitive, I think. Grok. I use both. Okay. It was trained through the Omniverse platform, which is what Jensen said. I believe that was okay. Yeah, Grok's not working with me here. I'm going to take a sip of coffee. Take a sip of coffee with me, you guys. All right. Grok's not giving me anything here. It's not giving me anything useful. So I'm going to say Isaac Labs. That's a physics-based simulation robotic engine. And man, from the droid Blue to Grek, leaps and bounds better. I mean, leaps and bounds better. And that's as simple as it's going to be put. Moving on. All right. You're going to need a Hans device for this. We're going to need our Hans device because your neck snap back on your head. Your head snap back on your neck when you see this. Here we go. Here we go. Now, I'm talking the new video of CL3 humanoid by Chinese company LimX Dynamics. Look at this gate. Look at this gate. Dude, this is a breakthrough. Okay, LimX Dynamics. I'm watching this thing. Incredible. So it's just walking through through a park. It actually looks like kind of in a city. It's walking on the sidewalk, and people are looking at it as it walks by because it's walking like a human being. It's swinging its arms. We swing our arms for balance, and I mean it's very smooth motion. This gait is on point, ladies. That gait. Your eyeballs be popping out your head with that gate. Jeez. Holy moly, that head, it's a rectangle head, and wowzers. This robot, LimX Dynamics, it's a Chinese robot, okay? The CL3 humanoid. China is leading the way in the AI and robotics revolution. Okay, that's why this robot is looking really good. It's highlighting this robot. The CL3 humanoid robot highlights its advanced mobility and integration into urban environments as seen in its smooth walking and interaction and with pedestrians and dogs in various outdoor settings. It's not afraid of those dogs. It doesn't even blink an eye. It doesn't even blink its humanoid electric eye. Not at all. It's just doing its thing. LimX Dynamics, the company behind the CL3 humanoid robot, was founded in 2005, making it a 20-year-old enterprise as of 2025. They have raised approximately $96.3 million in funding from investors including China Merchants, Kunsong Capital, and Vital Bridge. The CL3 robot itself has between 29 and 52 degrees of freedom. We're talking DOF. And again, you need DOF for DTF, okay? Humans, let's get it together. Let's get ourselves better. For reference, humans have about 200 degrees of freedom, and that's an athletic human. So robots are right there. They're getting up to us. Huh. So this robot has between 29 and 52 degrees of freedom. This company, LimX Dynamics, is making significant strides in robotics with the CL3 featuring 31 movable joints and a video gen motion system. Now, this video gen motion system, that's why this robot, the CL3 humanoid, is outstanding, dynamic, an engineering feat of software, and also the physicality of it and this video gen motion. Okay. This video gen motion is a proprietary software developed by LimX Dynamics. It's a system that teaches humanoid robots to walk by watching raw video footage of real humans and learning how to move like them using its own robot body. At first glance, this sounds like imitation learning. I've talked about imitation learning with robot training before, where the robot is shown a series of videos. The videos are broken down into frames. We're talking tokens, and then it has and then that's broken down into a little pixel. It's just a whole thing. Okay, so and then it needs to figure out the steps of what to do in order to copy the video of what a human is doing in a video. Okay, that's imitation learning. So this video gen motion sounds like imitation learning, and it is a form of imitation learning. It's imitation learning on steroids. That's what we're talking about, okay? The traditional imitation learning, this is it. Here's exactly what a human did. Now copy those movements step by step. That's traditional imitation learning. Video gen motion. Here we go. Watch how a human moves, understand the intent behind the motion, and then generate your own version of that motion, balanced, grounded, and adapted to the robot's unique body and physics. So it's not copying the video, what's in the video. The robot is not copying what's in the video. It is translating in real time. Real time, folks. That's incredible. That is mind. That's your mind. Blow out your butt, man. Oh. So we have, you might say, well, Lisa, NVIDIA and Gemini. We're talking NVIDIA, Isaac Sim, which is what I do believe is Greg, the Disney droid, was trained on. NVIDIA, Isaac Sim, they're Omniverse. Okay, we're talking Gemini on device. Well, we have these two things. What isn't that the same? Isn't that the same as video gen motion? NVIDIA uses simulation, Isaac Sim, and massive data to train robots in viral environments. It's powerful, but relies heavily on synthetic training and isn't specialized for human gait. That's how a human being walks. You're walking with a nice gait. A lot of human beings don't have a nice gait. Go work on your gait, folks. Go work on that gait. All right? Walking smoothly down the road. So NVIDIA is not specialized for human gait. Now this CL3 humanoid it's got that gait down. It's really moving smoothly. It's quite mesmerizing and weird. It's we're talking Gemini on device is a generalist AI brain that helps robots understand video and language to perform broad tasks. It's a VLA. As a vision learning action model. Walking is a possible outcome, but not the focus. Video gen motion is purpose built to decode human locomotion from video and transform it into walkable robot native movement with no in-between steps. That's what makes it mind-blowing. So just to sum that all up, video gen motion doesn't just mimic movement, it understands it. It teaches robots to learn gait like a human would by watching others walk, processing what's happening and adapting it to their own body. It's not just imitation, it's autonomous. Adaptive translation of human motion into robotic balance and behavior. Holy smokes. Holy smoke. Now that CL3 humanoid from Lem X, that got that real-time action chunking. Yes. Chunk it up, man. Chunk it up. Real-time action chunking. And I had someone ask me exactly what real-time action chunking is, so I'm going to get into it. Loretta, love you. Sending love out to you. This is for you. This is for everyone else. Here we go. Real-time action chunking is like a robot learning to dance one move at a time and being able to adjust the routine while performing it based on what's happening in the moment. Now, that doesn't quite mean anything because you don't really have anything to compare it to, so let's compare. All right? The old way, pre-chunking. The old way is called pre-chunking. Robots followed long, rigid motion scripts. This is the old way of training a robot, and that's called pre-chunking. So, for example, they followed a script. Step A, then B, then C, no matter what. Okay, so you got a robot, it's going to do a task, and it's going to, has inference, it's thinking, and then it's the thinking, and then it thinks about all the steps it needs to do before it does a task, like pick up a coffee mug. Well, it needs to maybe take a step forward, it needs to pick up the mug, all these things. So it's step A, B, C, it quote unquote downloads all of those steps, and then it starts doing the action, no matter what. So something could change. The cup could, it could move. It could be an earthquake, cup could move. Something could change. The handle on the cup, a human might come by and bump the handle, and now the robot would download all the steps to pick this cup up with a handle that was in a certain place. Now the handle's not in a certain place. Now it's just sitting there, frozen, clumsily going about it because it's trying to figure out the steps. All right, that's basically motions were pre-programmed or pre-learned. If the environment changed mid-step, the robot would either power through awkwardly or just freeze, fall, or bail out entirely, and that's called latency. That's called bad latency right there. So think of it like watching a robot on train tracks. It's really fast, but it can't pivot. Okay, so that's the old way. That's called pre-chunking. Okay, now we got the new way. It's called real-time action chunking. That's the new way of training a robot. With real-time action chunking, robots break big movements into small motion units. That's called a chunk. Chunk. Like a chunk of cheese, man. I'm hungry. Let's go. They can process independently, reorder on the fly, adjust mid-move. I'm talking, we're going to go back to the coffee mug situation. So if someone come by, bump that coffee mug, and now the handle's on the other side, and while the robot was in the midst of reaching for that mug, now with real-time action chunking, it's able to think and reorder its steps on the fly. So the robot's walk it's not a script. It adapts stride, balance, and recovery moment to moment, just like we do when tripping over a shoelace. And now what I'm saying is really basically is it's learning like a human being. That's what's happening. That's what's happening, folks. Video gen motion. We're going back to the C3 robot, the C3 humanoid. Okay, by LimX Dynamics. I'm sorry, not C3, the CL3 humanoid. Apologize, LimX. We're going to go back to the CL3 humanoid by LimX Dynamics because which has that video gen motion, which is super impressive. It likely uses this kind of real-time action chunking to take the gait pattern learned from video, break it into functional motion units. For example, lift a leg, shift weight, place a foot. Then recombine and adjust them in real time as the robot walks. This is what lets the robot respond dynamically, not just perform a pre-recorded motion, but actually walk with balance, react to slopes, or shift mid-stride like a human would. So again, just to sum this up, the old way, robots stuck to rigid scripts. If something moved, like they're in the midst of grabbing a coffee mug, someone come by, bump it, the coffee mug handle move, they're just stuck, they're frozen usually, they're clumsy. Okay, that's the old way. The new way, real-time action chunking. Robots move in flexible modular chunks so they can adapt on the fly. Oh, the robots are fly. Yes, Gertrude, they fly. Oh, they fly now. Yes, Gertrude, and what I mean by fly is they cool. They cool. Oh, fly can mean cool. Yes, it can mean cool. I don't. Oh no. Okay, moving on. Video Gen X. Video Gen Motion. The LemX's Video Gen Motion. Does this software run directly on the robot? I was very curious about this. And that is, I talked about the Gemini software that runs directly on the robot. That's called Gemini on device. Okay. That runs directly. It's the AI brain that helps robots understand video and language to perform broad tasks. Now, this is different than the Video Gen Motion, but it runs on the robot. So it doesn't need the cloud. It can run the cloud. Okay, the cloud. We're talking Video Gen Motion probably runs on the device, the robot. Sorry. I don't call it a device. It runs on the robot. So it doesn't... based on demos and research, Video Gen Motion is designed to run on device directly on board the humanoid robot. It doesn't require external servers or offloading to the cloud. All processing, visual motion planning, balance control, and gate execution happens on the robot's hardware. That's incredible. That is incredible. This aligns with other on-device AI efforts like Gemini Robotics on Device, which is what I just mentioned. But again, LemX is specialized. It's not trying to solve every task. It's optimized to walk beautifully and adaptively, and that's what it's doing. It's doing that, man. It's amazing. Gosh. Gonna take this Hans device off now. We got another Hans device worthy video coming up, so stay tuned. China is increasingly leading in AI and robotics with companies like LemX Dynamics with their CL3 humanoid, which is the one we just talked about, contributing to the global advancements of humanoid robots as evidenced by their focus on reinforcement learning and embodied AI, which are critical for real-world applications. And I'm very curious about how many chips a robot takes, and chips are super expensive. If humans needed chips to run, well, I guess let me think about that. I mean, we need things to function in this society. So I guess you could call those things chips. So it might be, robots aren't going to need much to function. They need chips. They need to be plugged into the grid. Now, we need to be plugged into Earth, to the Earth, meaning we get our vitamin D from the sun. We got to be plugged into those wavelengths, those light wavelengths. Light does a lot for us. We got to be plugged into Earth. So these robots, they're going to need to be plugged into the grid, to the satellites. And then you're going to need some chips. They're going to need chips. And, I'm hungry, so now I'm thinking of potato chips. But let's move on from that. They're going to need some chips to handle various functions, such as processing, sensing, and control. So this LemX Dynamics CL3, we're talking chips for a central processing unit, okay? That's a general computation and control. We're going to need a GPU, that's a graphic processing unit, and that is for handling complex AI algorithms, vision processing, and machine learning tasks. We're going to need a field programmable gate array, and that's a FPGA for short. And you might need a couple of those for real-time processing and can reconfigure for a specific task. Then we're going to need a application-specific integrated circuit. That's another chip. That's a custom chip designed for specific functions like motor control or sensor data processing, typically 1 or 2 chips. We're going to need a microcontroller. We're going to need several microcontrollers for managing individual components like joints, sensors, or actuators, often ranging from 10 to 20 depending on the robot's complexity. Then we're going to need, and inside an actuator, you got a harmonic device. Okay, a harmonic reducer inside an actuator. So then there's that component of it. Then we're going to need some memory chips, multiple types, including a RAM for temporary data storage and flash memory for persistent storage, usually several chips to handle different memory requirements. That's a lot of chips, guys. That's a lot of chips. Okay, so this specific robot is likely around 10 to 20 chips in total, probably more. Combining these categories to support its 29 to 52 degrees of freedom, and there's a direct correlation between chips and DOF. And that is degrees of freedom. And, I mean, man, this thing's making some strides, man. We gotta catch up. Gotta catch up. This thing is learning like human beings. That's all I'm saying. And I'm going to go on this down the road here with chips. Now, I just explained the components of what goes into a humanoid like CL3. There's a lot of components that go into a humanoid. This is not a garage DIY project. If you're going to make, I mean, it could be, but not a scalable one. I mean, if you're going to make scalable humanoids, you're going to need a lot of money. You're going to need a lot of cash. That cash money. That's what I'm talking about. All right. I mean, there's just so much that goes into it. And there's other, I mentioned NVIDIA a lot because NVIDIA is the gold standard, but there's also Unity or it's called ROS 2. And those are other ones that people can use. So, I mean, there's just, man, I'm talking about things that, components that go into building a robot. You got LiDAR, you got sensors, you got actuators, cooling systems, all manufactured, tested, tuned by humans. You got custom designed printed circuit boards where electrical components like chips, sensors, power connectors are mounted and wired together. R&D phases, for example, Figure, that's Brett Adcock of Figure AI. They raised $675 million Series B, led by Microsoft, OpenAI, NVIDIA, Bezos, etc. That's 675 mil plus. All right. We're talking Tesla Optimus. We're talking about T-Bot. All right. That was $1 billion, likely $1 billion in R&D and across the teams. Agility Robotics, their flagship robot is Digit. It's the cutest thing in the entire world and the best social media page. I mean, Digit has the best page and it's got those bird legs. That's that biomimicry. It's mimicking those backward legs. And we're talking 180 mil plus, and that was funded by Amazon and others. So that's just a lot of cash. The cash money, that cheddar. To get a scalable robot up and running. And these chips, they're a big part of this. Man, these chips are expensive. A humanoid robot like Figure is, and I'm telling, like a robot, it's not just like one big old chip that you put in, you're like here, and then you click this chip in. You got a chip, and it's like this, and you're like, you're latching it in there, and then off the robot goes. It's ready to rock. Ready to go to market. No. What? No. So it runs on a whole network of processors. There's usually a main AI chip like NVIDIA's Jetson Orin. Now that I believe we're talking about, AGI. That I do believe is the autonomous vehicle chip. But so that's 20 to 30 microchips handling each. Okay. Jetson Orin is also an autonomous vehicle and humanoid, apparently. So we're talking 20 to 30 microchips handling each joint's movement. You add in the cameras, the sensors, power systems. You're looking at 40 to 50 chips working together just to help the robot walk across the room without falling on its face. That's just to help that. And then you got harmonic reducers, all right? Every smooth, precise movement you see in a humanoid robot, whether it's walking, waving, or pouring coffee, is thanks to a tiny mechanical marvel called a harmonic reducer. It's a high torque, low backlash gear system packed into each joint, turning fast motor spins into stable human-like motion. Without it, your robot would be wobbling like a shopping cart with a bad wheel. And I've talked about that shopping cart with a bad wheel last week. You get that shop, you're going grocery shopping, you pull that cart out. You don't realize it has a bad wheel until you get going in the store for a little while. And then you go to, and then you're just shopping along, going a straight line, making a beeline for those bananas. And then that wheel give out and now you're going for a hard right turn you never thought you were going to go for, and into the bananas you go. And that's what I'm talking about. Okay. So you need the harmonic reducers. So your robot don't be going into the bananas, basically, okay? Most humanoid robots use around 20 to 30 harmonic drives, one in nearly every major joint. These are not just gears or precision reducers that help the robot move with smooth human-like motion. And a chip, I just want to make it clear for those of you out there who have heard of a GPU, which is a graphic processing unit, a chip's not necessarily the same as that. Chip is a broad term. It's any integrated circuit. A GPU is one type of chip. It's not all chips, it's one type of chip, okay? So we're talking, how many total chips are in a humanoid robot? We got the central brain. That's 1 to 2 chips. We're talking about NVIDIA Jetson, AGX, Orin. Per joint, degrees of freedom. Chips seem to have a direct correlation to those degrees of freedom. And they seem to, I'm just going to say right now, they do have a direct correlation of the degrees of freedom. Bear with me while I figure out how to read a paper with a microphone in my face. We got, per joint, degrees of freedom, 20 to 30 microcontrollers, digital signal processing. Then we have the sensors, 6 to 12 sensor modules, each with their own embedded chips. Power battery, 5 to 10 small support chips. Got a lot, all right? That's a lot of chips. That's a lot of money. I mean, that's billions. That's just millions and millions of dollars, if not a bill, at least. Okay, so back to LimX. Okay. CL3, LimX Dynamics CL3. I mean, again, China is making strides here. And one question I had for myself in my head, so I'm going to say it out to you guys. I mean, here we go. It's in my brain. I'm going to show you the inside of my brain. This is so fun. Love being here with you guys, showing you the inside of my brain. My brain is just peak absurdity. It's a Looney Tunes, Warner Brothers cartoons, just all packed in there. Peak absurdity brain cage. I was thinking the other day, whoever wins the AI and robotic revolution wins the world. Is that true? Kinda. Kind of. There's a lot of things that go into that. There's a lot of things that go into winning the AI and robotic revolution. It's a trifecta, really. It's the AI, robotics, and chips. Because you can't have a robot without a chip. They need chips. They're desperately they need some chips. And if they want some gate, they're going to need some harmonic reducers. So is that true? Is it true? Whoever wins the AI and robotics and chip trifecta gains a massive strategic and economic advantage. Yeah, it's kind of true. I mean, it's true. But here, this is all the parts that go into it. This is it. AI. It's the brain power behind modern innovation. It drives everything from predictive analytics and finance to autonomous systems in defense. Robotics, pair AI with robotics, and you got the muscle to automate manufacturing, logistics, and even warfare. Self-driving tanks, factories that run 24/7 without coffee breaks. Excuse me. I had a burp in my throat. Excuse me. I'm going to take a sip of water. Go ahead, guys. Use that to hydrate. Go ahead, hydrate yourselves. It's hot out there. It is balmy. Hydrate yourselves, okay? And then you got a sip of water, and then you're going to chase that with some coffee, which is going to dehydrate you. But your liver is going to be good for the liver, I think. I don't know. Here, drink some coffee. Let's go, liver. Let's go. All right, so we're hydrated, and we're caffeinated. Yes. Talking about who gonna win this AI robotic chip revolution thing? What's going on? Okay, so you got AI robotics, advanced chips. They're the beating heart of both the AI and robotics. Cutting edge semiconductors enable faster, more efficient computing. We're talking Taiwan Semiconductor Manufacturing Company. That is the company that controls the chip supply right now, today. It really does. It's the world's largest and most dominant producer of semiconductors, aka the tiny chips that power everything from your smartphone to your car's navigation system. It was founded in 1987. That's great. Let's fast forward. It produces over 50% of the world's semiconductors and 90%, here, give or take 90% of the most advanced ones. If you're using a modern device, then you got if you're using a modern device, then the Taiwan Semiconductor Manufacturing Company, its fingerprints are probably on it. And what they did, the very intelligent thing they did is they started their company in 1987, and they specialize in making integrated circuits, microchips, for other companies like Apple, Nvidia, and AMD without designing or selling its own branded products. That's what they did. And that was the juice behind what they have become today. Unlike, I'm talking, Intel makes chips, but they put their brand on it, and it held them back, man. Held them back. I think. I don't know. What am I saying? That's just my 2 cents. What do I know? What am I talking about? Let's move on. Okay. What am I talking about? I'm talking about the Taiwan Semiconductor Manufacturing Company. Take a gander where that's located. In Taiwan, what? It is? Yeah. It makes it a focal point in the U.S.-China tensions, as both powers rely on their chips. A distribution could tank the conflict, or a natural disaster could tank the global economy faster. I mean, faster than anything you've ever seen, okay? Faster than a meteor hitting this earth. It'd be so bad. Now, the Taiwan Semiconductor Manufacturing Company, they pioneered the foundry model in the 1980s, making chips for others without designing them. U.S. companies like Intel focus on designing and manufacturing their own chips, but TSMC, that's what I'm going to call it, all right? Taiwan Semiconductor Manufacturing Company. It was laser focused on contract manufacturing, which made it insanely efficient. By the time the U.S. realized what they were doing, the Taiwan Semiconductor Manufacturing Company was eating our lunch, basically. So they're the chip king. They're the king of the chips. Why don't we just build a factory here in the United States? Sure. Oh, sure. Does anyone have some chump change? I mean, does anyone have about $15 to $20 billion laying around that I can build myself a semiconductor factory in the United States? That's a lot of cash. Money. It's super expensive. Okay, the Taiwan Semiconductor Manufacturing Company, they've been doing it for decades. They've got dozens of fabs optimized for scale. Even if someone had $20 billion to give someone to start a factory here, it's going to be a long Irish road. It's going to be painful and expensive. So that's where I'm at, okay? That's where I'm at with that. The verdict of, bear with me. Let's get back on track to the AI and robotics and advanced chips. So what I'm answering the question is, whoever wins the AI and robotics and advanced chip trifecta gains a massive strategic and economic advantage. Yeah, pretty much. So because we're talking AI, robotics, advanced chips, whoever gets ahead of that. I mean, so there's a lot involved with this, right? We got the Taiwan Semiconductor Manufacturing Company that has the market hold on the chips. China has us beat, man. They got the AI and robotics revolution. They're coming up ahead. They're beating us. In the United States, we have some things. I mean, there's just so many pieces. It's not like chess. It's not like, there's just a lot of segments to this. There's strategic and economic advantage. Dominating the trifecta, which is the AI, robotics, and chips, means you can dictate terms in global markets, secure military superiority, and fuel economic growth through innovation. China's push for chip self-sufficiency and the U.S.'s CHIPS Act I'm not familiar with the CHIP Act. I'll have to read up on that, but it shows how seriously nations take this race. Autonomy in these fields reduces reliance on rivals, which is critical in a world where tech sanctions are a thing. Tech sanctions are a thing, man. Not a solo act. No single player or company will win all three overnight. That's what I'm saying. Super hard to do. And yeah, so I mean, building this trifecta requires obscene amounts of money, talent, and infrastructure. We are getting a Taiwan Semiconductor Manufacturing Company plant in Arizona, I do believe. And again, someone just have $20 billion just laying around. But we have them behind it, so we got all their technology, but still, it's a Taiwanese company. They still got the market share on it. So that's super interesting things to me. I hope you find it interesting to you as well. Moving on. All right. We're looking at Unitree G1. This video from G1 is currently going viral. With all the challenges that still exist, it has to be said that we have already come a long way. All right, we got a robot. We got the Unitree G1. That is the Chinese company, Unitree. And I'm not going to, I can't pronounce their real name, but they do go by Unitree. I'm talking about their real Chinese name. Because Mandarin, I tried learning it. Got a long way to go on that. Anyway, a Chinese robotics firm, which is Unitree, founded in 2016. They recently closed a Series C funding round. The past money valuation is most commonly reported around 12 bill. Oh, hang on, that's yen. $1.7 billion. All right, so that's some serious cash money. And now we're looking at this Unitree G1. And what it's doing is, it's in a park. It's running. All right. It has an outfit on. It's got some hair. It's got some green hair, and it's got an athletic jumpsuit on. It's silver. It kind of looks like aluminum foil, but it's very futuristic. Obviously, it's a robot wearing a tracksuit and green hair. Okay? And his face looked like a ring light. And it's running in this park. It's running, and then boom! It runs into a tree, man, and its hair goes this poor thing, and then it just stops. Like, what just happened? I think it peed its track pants. It peed his pants. It hit that tree. That tree didn't even know it was coming, man. That tree is not used to seeing a robot. That tree is just out there doing its thing in the wind. It's like, glory to God, I'm here. I'm taking in some sunlight. I'm getting my photosynthesis, this tree. And then, boom, a robot with green hair and a silver tracksuit hit it. Good dude. And the robot, I think it kind of got surprised and peed his tracksuit pants. Whose robot is out here running around the park, running into trees, man? Someone get their robot. Whose robot is this? Call your parents. Yo, robot, call your parents. My parents is a lab, man. I don't have a parent. And that's what we're going to be coming by when they become sentient. But so this dude, he run into a tree. He's okay. I mean, no parts went flying. Nothing like flew off him. His hair stayed on. His tracksuit stayed on. Got a little wobbly and we're going in. Push! You know what though? I'm laughing because we all know what it's like to hit a tree. When we're young, you're running. You don't look up. When you're a kid, that's what this robot, you don't look up. You're just running. You run into a tree. We all know what that's like. We fall back flat on our derrieres. Gadoosh. He didn't even fall back on his derriere, on his robot derriere. He took a minute. He got rebalanced on his leg. Then he kind of stopped for a minute just to get his head right. He's like, his brain just kind of like shook around his robot head. Those chips, they shook his chips. Running into this tree, it shook his chips a bit. His chips got back on track. Then he started going on his merry way. And then he comes and he runs up to the camera. And he's like, Ma, did you see that? You see me run into a tree, man. And then, he almost ran into that light pole. He almost ran into a light pole. And he's kind of like, he's kind of like looking up like, oh, that was a rough go of it. I run into a tree. The tree is surprised. I'm surprised. Pee my pants. Almost run into a light pole because he's like trying to get over the trauma from the tree run-in. But then he stops. He looks up at the sky. He's like, what is happening? And then he regains his position and everything's good. Moving on. We got a shapeshifter. I'm talking about Nio Robotics, and that's a French company. Merci beaucoup. They talk the French. I am French. Obviously, not over from France because I'm really loud. French people, they're not loud. They talk more like this. They talk more like my great-grandmother. She only spoke French. Merci beaucoup. Merci beaucoup. Oh, pont neuf. Beignet. These are, everyone watched Madeline? Anyone watch that as a kid? I think she was French. Anyway, moving on. So there's a French robotics company called NIO. And I'm going to pop this video up here and, of course, explain it for anyone who's just listening. Oh, my God, this thing. Okay, here we go. It's a series of arms, okay? So you got an series of arms. I'm talking like a forearm that's connected to a bicep, and it's a series of that, okay? You got like just a series of that, and it's very agile. And it kind of like... It can go through anything, okay? It's going right now. I'm watching here. It's got some wheels on it, okay? The series of arms got wheels on it. It's going up some stairs. It's moving about the factory. This is a factory setting. It's taking itself to work. It's going to work. It's working. There's some cones that came across, some orange cones. It's contorting its body that is just arms and wheels so that it can get around everything. It can fold itself up. It can flatten itself out. Now it's going up to a locker, and this is in a factory setting. You know, with those floors that they're like grate floors, grated, the holes in it. Now it's opening a locker, it looks like. And it's got one of these arms that comes up. It like unattaches itself to the rest of the robot. It comes up. It has a little grabber and it opens the door. And then it like, it's fixing some electrical circuits. Oh, geez, crime in LA. It is quite alien looking. It's for inspection. It's an inspection robot. It can unfold to manipulate its environment and open doors. And here's the thing. It's multi-joint arm and gripper equipped maintenance and inspection robot. The post discusses the capabilities of the robot Aru. It's ARU. That's the robot's name. Developed by NIO Robotics. Focusing on its industrial applications for automated patrols, fault diagnoses, and real-time monitoring to minimize downtime. About to plug in, get some. Okay, so here's the thing, guys. Here's the thing. You at work, all right? You know that, you don't know that Aru is out there. Aru by NIO Robotics. This arm-only wheelie robot. It's just wheeling around, snaking through things, and then you're going to get some lunch, and this robot, it come up next to you, and it open up a locker, and it takes someone else's lunch. Because it can do that. It can do whatever it wants. I mean, you're walking down that railway, those stairs, and this thing be climbing itself up. I mean, I say maybe it's like crawling itself up. And then you stop and you're like, just tilting your head looking at this thing. It can't talk to you. It's just moving along and you're in its way. So it's like, it can't talk to you, but it's thinking. You can feel it thinking like, yo, get out my way, man. I'm a robot. I got chips, man. What do you have? Squishy organs? You squishy organ human, get out my way. I'm going to get up to this locker, take that guy's lunch, man. That's what it's doing. That's what we're going to come across. Moving on. Nick Bostrom. Shout out, Nick. Nick Bostrom, my man. Nick Bostrom's book, Super Intelligence, that was written in 2014. That was the first book that got me into AI. And if you haven't read it, good luck. I did a little bit about Nick Bostrom. I'll pop that up. That was a while ago. I think maybe a couple of years ago. I did a little comedy sketch, whatever you want to call it, about his book. Not really understanding it, but I forged ahead with it anyway because it's quite interesting. It talks about like rabbit retinol DNA. I don't really, guys, you got to go read it for yourself. Anyway, I've known of Nick Bostrom for a long time. He's been very consistent in the AI world. He says, this is the golden age for purpose. Right now, you can help steer the future of humanity with AI, but if things go well, there may be nothing left for us to do. Let me see if I can get this soundbite on here. Bear with me. Whoa. Hang on, guys. Yikes. What is that? Bear with me. Something else is playing on my computer. Okay.
Now,
sorry about all that noise. Here we go.
I think having purpose is an intrinsically valuable part of human existence. Now is the golden age for purpose, right? Like knock ourselves out right now. Like now you have all these opportunities of ways that you might help in the big picture to steer the future of humanity with AI, or in your community or in your family or for your friends. But like if you want to try to actually help make the world better, now is really the golden age for that. And then hopefully if things go well later, all the problems will already have been solved. Or if there remain problems, maybe the machines will be just way better at solving them, and that we won't be needed anymore. But for now, we certainly are needed. And so take advantage of that and try to do something to make the world better.
Wow. We could be the last generation that has any purpose, which is just so crazy to think.
Yeah, of that sort of stark, urgent, screamingly morally important type.
Dude, and that's by Virtuopo. It's VITRUPO, and that's a post that they posted. Woo, that is heavy. Let's move on. It's heavy positive? Let's move on. All right. We got the, oh my God. Okay, this is Hans of Ice material right here. Guys, put your Hans of Ice on because your head about snap off your neck. Here we go. Protect that neck. Protect that neck. Researchers from ETH Zurich, that's otherwise known as the Swiss Federal Institute of Technology, Zurich. That's what we're looking at here. They have developed a new tech called the elastic rolling cam. That's ERC, giving robots a kind of mechanical memory. A mechanical memory. Okay? We're talking about memory in a robot. All right? So researchers at this Zurich, ETH in Zurich, okay? They developed a new tech called the elastic rolling cam, giving robots a kind of mechanical memory similar to how animals naturally move. Elastic rolling cams let robots store motion in their joints by adjusting stiffness, like building instinct into hardware. What? Dude, this allows for complex adaptive movement with almost no real-time control. A biped robot with an elastic rolling cam knees walked smoothly over uneven terrain without active feedback. A drone with this technology, the elastic rolling cam, joints even morphed into its shape on impact. A drone morphed its shape on impact, showing smart, flexible reactions. That's like a human being, okay? That's like a human being, guys. This is happening really fast, okay? These developments, people all over the world are working on this. This is from Zurich, all right? We're talking about the elastic rolling cam. And this video that I'm showing you here up on the screen, it is oh my God. Okay, we got 2 legs, and that's what this robot is. It's just a flat rectangular box, it looks like, with 2 legs on the end of it. And this is connected to a pole, which is connected to a central unit that is fastened to the floor. And it's walking around in a circumference. And they have a block on the floor that would be something to maybe slow it down. See what this biped does with this block on the floor. It kind of looks like those horses. What is that? Back in the day, where they'd have horses and they, I don't know, was it a carousel? They put them on. They hook them onto a carousel and they go around in a circle. Anyway, moving on. Back to this. Not moving on. Back to this. This is wild. So basically, it's walking smoothly over this block on the floor, uneven terrain, without active feedback. It's adjusting its joints on the fly. Right, here we go. It's boom. It walks over the block. without active feedback. That's incredible. Wow. All right, moving on. Jeez, we're talking about muscle memory, man. That's mechanical muscle memory. That's insane. All right. Up next, this is the last one. Brett Adcock of Figure. He is investing. He's got a new investment to keep schools safe. This is technology here. We're talking. And this technology that he's investing in to keep schools safe, you can also integrate it into a figure. It's called Cover is the company, and it has a Gen 2 hardware. It can now detect weapons hidden under clothes or inside bags. The image here is from an early prototype. It shows a gun detected under a hoodie. Over time, this kind of technology needs to be in every major public venue around the world. That's Brett Adcock. He is the CEO and founder of Figure Robotics. And again, this hardware that can detect weapons hidden under clothes or inside bags, this can be integrated into his humanoid. And what I'm thinking, man, you know, Brett should get together with Icon, which is a 3D printed housing company I'm always talking about. They got that gantry style 3D printed, a 3D printer called Vulcan, and their proprietary housing material called, what's it called? Oh boy, Maglev. Nope, Lavacrete. Lavacrete. Okay. Anyway, he should get together with this 3D printed housing companies, you know, because technology, robots, and, you know, like realtors who sell it. They can say, hey, if you get this 3D printed home, you can get cover into your Figure robot. If you're going to get a domestic robot, that's going to be Figure. You can get cover for free for like a month. And why would you want that in your house? So you got your domestic robot in your house. Yeah, I want that. I want software in my domestic robot that can detect if someone has a firearm or a weapon on them coming up to my house, even if it's a friend, man. You know, like Lindsay coming up to my house, okay? Or like Madeline walking up to my house. I know she carries, but she got that, my domestic robot Figure is like, yo, Lindsay got a gun on her today, and I got a toddler at home crawling around on the floor. I'm like, yo, Madeline, you better glue that purse onto your shoulder the whole time you hear. All right, don't be putting that thing down, man. Like, you know what I mean? Something like that. I think that'd be cool. And Brett Adcock, he says every cover scanner will have the option to add Figure humanoid robots for 360-degree live surveillance. 360-degree live surveillance and real-time situational awareness on the ground. That is so cool. And on that note, I'm going to end on that note, all right? I hope you guys, again, happy July 4th. Happy Independence Day. I hope you're all having a good time, eating some good food, spending some quality time with family and friends. Out there getting crunk. You getting crunk on honey, like I'm about to do. My husband and I were about to go get some crunk on some bee shite from that bee butt. Bee shite, man. Go enjoy some honey this July 4th. Hope you're having a really great time. All right. Send in some positivity and love towards you and your way. Sending it your way. I'll see you next week. All right. Bye, everyone.